Okay, this video we're going to look at some examples of solving literal equations. Something we need to be able to do all the time. Basically, we just mean algebraic manipulation of equations without numbers in them. That's all we need. All we mean by literal equations, math without numbers. On the left there, I've put up our order of operations in the direction of the red arrow, which would be parentheses, exponents, multiplication, division, addition, and subtraction is the way we would evaluate an expression and solve if we had values for it, which I'll show you an example of. I know you're familiar with it, and that's how our calculators would solve something if we typed it in. And the other direction, in the blue arrow's direction, is how we would go for isolating and solving for a particular variable. Okay, so we'll see a few examples of that. First very simple equation, which we will encounter very soon. Say I have v equals v naught or v0, I'll often say v naught, plus at, and we want to solve for v. V in relation to v naught usually means the final or the later quantity, and naught usually indicates the former or the initial quantity. So here we have some values for those variables. We plug them in, and 2 times 3 is evaluated first as 6, then added to 5 when we get the final answer. 11, we would not, on the other hand, we would not do 5 plus 2 is 7, times 3 is 21, right? Because you follow order of operations, and that's what our calculators will do. Now, if we were to ask, say, without putting any numbers in, solve for t, then what we would have to do is then first subtract, go in the opposite direction, following our blue arrow for order of operations, subtract v0 or v naught from both sides, so we'd have v minus v naught equals at, and then we would divide both sides by a, and then we've isolated t, v minus v naught over a is equal to t. So just some examples. Feel free to pause after these are all written up and try to solve them yourself. Starting from the left is the way I'm going to do them. In quotes above the equation is the variable I would like for you to solve for. And the ones that involve delta x and delta y, you can treat those as individual variables. So you keep them together. The delta x is a package. It stays together unless you separate it out into x2 minus x1 or x1 minus x naught. Same thing for the y. The delta just means that difference in, just like y2 minus y1 in the slope equation can also be written as delta y. You can move that delta y around without, you don't separate your delta, your triangle symbol, and the letter variable. So let's start with the left there. We're going to solve for t. First thing I'm going to do is multiply by 2 on both sides. So we have 2h equals gt squared. I need to take the square root of both sides there after dividing by g. So I have the square root of 2h over g equals t, because I divided both sides by g and then took the square root. But I'm not quite done yet, because mathematically we could have a positive or a negative root. Once squared becomes positive. So I have plus or minus the square root of 2h divided by g equals t. Put a box around it. Next example on the right, we're looking for a. So I have first step there, I'm going to subtract v naught or v0 squared to the other side. So the whole package, v naught times v naught, which is v naught squared, that whole package gets subtracted from both sides, so we have v squared minus v naught squared equals 2a times delta x. So that's 2 times some variable a times some variable delta x. And that delta x represents some difference. So here in blue, here's an example of what it could be. Now it could be x minus x naught, giving us some difference, treated as a single variable. And so we'll divide both sides by delta x. And now we have v squared minus v naught squared divided by delta x equals 2a. Got to divide both sides by that 2 because we're trying to isolate a. And there we have v squared minus v naught squared divided by 2 times delta x equals a. Box around it. Next one, we're looking at some fractions. This time I want to solve for s, so first I need to subtract 1 divided by f from both sides, so that I get 1 divided by s, or 1 over s, by itself there on the left side of the equation. Then I need to take each side of the equation to the negative 1 power, because I want s to be s over 1, not 1 over s. So solving for s is the same as solving for s divided by 1. So I need to flip both sides of my equations. both sides of my equation, and right now I have 1 over r minus 1 over f, all of that to the negative 1 power. So first I need to combine these two fractions, and they need a common denominator in order to do that. So that's what I get if I multiply both denominators by one another. So the fractions haven't changed, they just have the common denominator now, and I can therefore combine them. So I have f minus r divided by r times f. And all of that is to the negative 1 power, because I had to flip it to get my 1 over s into an s over 1. So now I can get the reciprocal or express it there so I don't have that negative 1 exponent, and I've solved for s. Last guy over there on the right, we have an equation we're going to solve for t, and a t appears twice there with the different orders of magnitude. So our different exponents. So first we got that delta y. Over on the left side we're going to subtract and bring it over to the right. And we have 0 equals v naught t minus 1 half gt squared minus delta y. Delta y, again, that's just like the delta x treated as a single variable. And if I rearrange things a little bit by the order of my t's, I have that third line there, and we notice this looks very familiar, doesn't it? It looks like a quadratic function. And indeed it is, which we will see in the next couple weeks. And we do want to be able to solve these, though we will not be required to deal too much with the quadratic formula. We will do it now, and you should be able to do it. So I notice which coefficients a, b, and c correspond to which values in my particular quadratic function I have. And so today it looks like minus 1 half g corresponds to my coefficient of a, v naught corresponds to my coefficient b, and my last coefficient c corresponds to my minus delta y. So we're going to write it up again, see if I can recall my quadratic formula. There it is, and now we're going to substitute in those variables for the values that they are in the quadratic formula. So as we mentioned before, and as it's written again, those are my a, b's, and c's. Check to make sure that you see where those are being substituted in. I was very careful. I put some parentheses around each of those quantities to make sure I maintain my proper signage there. And so the first step I'll go through is I'm going to say, evaluate my stuff under my, or simplify under my radical there. I have a positive 4 divided by 2g. That's still times a negative delta y. So that sign will flip again, and it'll be over negative 2 divided by 2g. So I can simplify this some more. There I have that minus 4 over 2g delta y becomes minus 2g delta y. My minus 2 over 2g in the denominator just becomes minus g. And I have minus signs that cancel out upstairs and downstairs, and I'm left with v naught plus or minus square root v naught squared minus 2g delta y divided by g. And we very much will be interested in seeing how that plus or minus part in there before the radical gives us different values for t. So we have found, this is the equation that shows us it is equal to t, which was our variable we were solving for. So t is equal to v naught plus or minus square root v naught squared minus 2g delta y divided by g. So there could be two values for t there. Alright, so wrapping up so far, we have covered, it's been in about, it's Wednesday, so in about a week, this is kind of the things we've been looking at and reviewing. I'm sure most of it is review for everybody. So a little bit about literal equations, just algebraic manipulation of equations with no numbers in them. Big on that. Basic and inverse trig functions, sine, cosine, tangent, and the inverse functions, the arc functions that get us back to the angle. Need to be able to use those in relation to right angle triangles. Uncertainty, error, percent error, a little bit about accuracy and precision, and the qualitative reasoning, like saying where does the greatest source of error come from and why do you think so. Very important on our AP test. And number 4, collecting and graphing data. We've done some of that for our Pi lab, and we've done that for our rebound height, which we will test tomorrow. And remember our rules for finding lines of best fit and the linear equations that go with single linear fit. Have this rebound height data for tomorrow, and expect Friday a quiz on all of this stuff. Friday we'll have a quiz that'll be on Can you solve some literal equations? You may or may not see the exact ones in this video. Can you use some basic and inverse trig functions to find the relationship between angles, like the opposite side or the height, just like we did in our height lab? Can you tell me what the angle is when given the other information and use the arctangent or arcsine functions? Can you calculate percent error? Can you draw a line of best fit and give me the slope using the appropriate techniques we talked about? That kind of stuff. We'll have another video tomorrow on a few more examples of literal equations, and that'll be it.